relational database system, and then at the end, the relational database system would receive the data wholly. Next, my friend Seto will present about the export scope import export. However, he will present it by his own screen. So I'm going to stop sharing.
All right, thank you, Rika, for your exposition on the Scoop architecture. So now I'm going to briefly discuss Scoop's main function, which is to perform bulk import-export of a structured data type between Hadoop environments and the external data stores. Hang on. All right. Can you guys see it?
Yep, we can see it.
Yes.
All right. So I'm going to briefly explain Scoop's main function, which is to perform bulk import-export of a structured data type between Hadoop environments and the external data stores. So the Hadoop environments include Hadoop Distributed File System, or HDFS, which is the primary data storage system used by Hadoop applications. And then there's also Hive, which is a data warehouse inside Hadoop that facilitates SQL-like querying and analysis of large data sets. And lastly, there's Hadoop Database, or HBase, which is a column-oriented non-RDBMS that runs on top of HDFS to store sparse data sets and to support real-time random read and write of large volumes of data. Meanwhile, the external stores of a structured data type include Relational Database Management System, or RDBMS, enterprise data warehouses, and NoSQL systems. So before data sets can be used or analyzed by Hadoop applications, they need to be transferred from external source to Hadoop environments using Scoop import command, which is executed through a command line interface, or CLI, with a generic command scoop space import, then followed by some specific arguments as needed, such as this. So once Scoop command to import runs, Scoop client collects metadata such as column names and their data types. And then a Java class is generated with column names as fields and matching data types. And then map-only jobs are submitted to the Hadoop cluster. And following that, the rows of the tables are split using the primary key. And then each split is then assigned to one of the 4 map tasks that are created by default. And then finally, each map task transfers the split to HDFS via Java Database Connection API as a comma-separated values, or CSV file. The reciprocal process is to store the data sets after processing to the external data stores using Scoop export command. So it's Scoop space export, then followed by specific arguments as needed. Once the Scoop command to export runs, Scoop connects to the RDBMS to get the metadata of the table. After that, using this metadata, Scoop generates and compiles a Java class. The Java class is then used in the submitted map-only job, and then the Scoop divides the input data sets into splits. Each split is then assigned to one of the 4 map tasks that are created by default. And finally, Scoop launches 4 map tasks to transfer data from Hadoop to RDBMS. So yeah, that concludes our brief introduction to Apache Scoop. In short, Scoop is a tool that facilitates fast and reliable high-volume bulk data transfers between Hadoop environments and external stores, specifically structured data type. So yeah, thank you for listening, and we'll hand it over back to Mardhani.
Okay. Okay, thank you very much for the explanation. So what do you have some not summary, I think, but some word that that describe Scoop? It's very fit for what kind of data? that we can use for data gathering process. Hello?
I'm sorry, sir.
Do you, sorry, wait. Okay, do you hear my voice?
What was the question again? I'm sorry.
Okay, you hear my voice now?
Yes, I can hear it now.
Yeah. So not about the conclusion actually, but mostly like the point that the scope is work for what kind of data actually. If the when you and your team explain about the how it works, yeah.
Yeah, I think it fits for structured data such as tables or SQLs.
Okay, thank you very much. Okay, that's nice. Okay, thank you very much for the team for volunteering for the first presentation. Yeah. Okay, thank you very much. It's good point. We go on the next, the voluntary team by Muhammad Rauf, please.
Yes, sir. Wait, our friend will present first. Yeah. Thank you, Vira.
Is it up here already?
Yes.
Yeah.
Udah, Vira, udah.
Okay. Sure. So, good morning, Pak Mardhani and everyone in this class. Thank you for the opportunity for our group to present this. So we have already listened to Pak Mardhani explain about Hadoop, and also from the previous group that explained about scope. And now our group would like to explain about Apache Spark in the use of big data. And our group consists of five members, which are Chandra, me, Vira, and also Aziz, Rauf, and Norman. And then the next one is we would like to explain more. So I think I would like to give the floor to Chandra.
I think it is normal first.
Okay, sorry. Maybe Norman will explain this.
Okay, so Spark is basically a framework which provides some of interconnected platforms, systems, and standards for big data projects. Apache Spark is a unified analytics engine for large-scale data processing. It provides high-level API in Java, Scala, Python, and R, and an optimized engine that supports general execution graph. Okay, so I will pass it to my teammate Chandra. Right.
Okay, and Spark also supports a rich set of higher-level tools, including Spark SQL for SQL and structured data processing, MLlib for machine learning, GraphX for graph processing, and structured streaming for incremental computation and stream processing. I think this is sufficient to explain the purpose of Spark. And next, my friend Fira will explain the type of data.
Okay, so I would like to explain about the data types that are supported by Spark. Data types that are supported by Spark are actually very general, because there consists of numeric types, string, binary, and so on. But I would like to explain more. Maybe Spark can be Spark can be used in a lot of programming language, such as Java, Python, or SQL and Scala. And there are some method how to use it. And in Scala, we can run this command import org.apache.spark.sql.types. dot underscore, and then in Java we can also use the factory methods provided, and in Python we can also run it by the command here, yeah, and then also in R we can access it by connecting Spark R and R Studio, then run the Spark R session. And then the data type that are supported by Spark are numeric type, which also support byte type, short type, integer type, long, float, double, and decimal. And also there also string type, which we know that we can use it for writing to write words, and binary, Boolean, datetime, which are separated into two kind of data types, timestamp and date type. And then the last one is complex types, which support array and map and struct type. I think, yeah, that's all from the data type that are supported by Spark. Now we are going to explain more about the mechanism how Spark works.
Yes, so I will explain how does the Apache Spark works. So the driver runs in its own Python process. These drivers communicate with a large number of distributed workers called executors. Each executor is a separate Python process. A Spark application is a combination of the driver and its own applications. With the help of the cluster manager, a Spark application is launched on a number of machines. The standalone cluster administrator is Spark's default built-in cluster manager. Besides the built-in cluster manager, Spark also works with some open source cluster managers, such as Hadoop Yarn and Apache Mesos. And next will be continued by my friend Aziz.
Okay, thank you, Ralph. Now we will compare Spark versus Hadoop. Now it should be pointed out that Apache Spark versus Apache Hadoop is a bit of a misnomer. You will find Spark in most Hadoop distribution these days, but due to two great advantages, Spark has become the framework of choice when dealing with big data, surpassing the old MapReduce paradigm that made Hadoop stand out. The first noticeable advantages is the speed. Spark's in-memory data engine means that it can perform tasks up to 100 times faster than MapReduce in certain situations, particularly when compared with multi-stage jobs that require the writing of state back out to disk between stages. Apache Spark's directed acyclic graph has multiple stages that can be distributed more efficiently compared to MapReduce's two-stage execution graph. Even Apache Spark jobs where data cannot be fully stored in memory tend to be about 10 times faster than their MapReduce counterparts. The second advantage is the Spark API. It is considerably more developer-friendly compared to MapReduce and other Apache Hadoop components. The Apache Spark API is very developer-friendly. Because of the distributed processing engine behind simple method calls. The canonical example is that almost 50 lines of MapReduce code can be reduced to just a few Apache Spark lines to count words in a document. Below is shown written in Scala. By providing links to popular languages for data analysis such as Python and R, as well as more enterprise-friendly Java and Scala, Apache Spark enables everyone and application developers to data scientists to use their scalability and speed in a more accessible way. Okay.
Okay, I think that's all from our group. If there's any questions from anyone or Pak Mardhani, we would love to answer that. Thank you.
Okay, thank you for the presentation. Wait, you can hear my voice? Sorry. Hello?
Yes, sir.
Can you hear? Okay, sorry. Okay, thank you for the presentation. I think this is also your team already present the good point of the how the Spark works. Yeah. So my previous question, what the kind of the data, maybe the example of the data that we can work in for Spark?
I think I would like to answer the question. So, in my opinion, as what my team and I have researched before, Spark can be compatible with Hadoop data, and it can run Hadoop clusters or Sparks in Sparks mode, and it can process data in like input format, and also HDFS and stuff like that. So I think, yeah, I hope that answered the question. Maybe my friend, some of our team want to add some.
Okay. Okay, thank you the answer. Okay, thank you very much for this team to present the presentation, and we proceed to the next. Yeah, after Rauf, I think I will invite the group from Pandaya as Attalah Erlambang.
Okay, sir.
Okay, please. Thank you.
Can you see my screen, sir?
Yes, please.
Oh, yeah. Okay. Good morning, everyone. Today, my group will present our tools, that is Apache Kafka. So our group consists of 4 members. There's Fazan Ali Distira, there's Muhammad Nafal Zakir Rauf, there's Leo Harnadi Marlin, and finally there's me, Pandi Atal Herlambang. So without further ado, I will give Leo the chance to speak, to maybe give a little bit of background about what Apache Kafka is.
Yep. Hello, Pak Mardhani and friends. As Pandir have explained, I will be explaining about the first part of this report, which is event streaming. So this section will be acting as a background before we really get into the Apache Kafka. And in a sense, event streaming is like a digital equivalent of a human's body central nervous system. It is the foundation or the backbone of a world where businesses are increasingly software-defined and automated, and where softwares are used by other softwares. Technically speaking, event streaming is when data in real time from event sources such as databases, sensors, mobile devices, etc. are captured in the form of streams of events. And these event streams are then stored durably for later retrieval and can be manipulated, processed, and reacted to in real time as well as retrospectively. Not only that, they can later also be routed into different destination technologies as needed. And so as such, with event streaming, continuous flow and interpretation of data can be ensured. So with that being said, event streaming has multiple application in the real world in different industries and organizations. Now, these examples would include processing payments and financial transactions in real time, such as in stock exchanges, banks, and insurances, tracking and monitoring cars and other vehicles in real time for logistics and the automotive industry, continuously capture and analyze sensor data from Internet of Things devices or other equipment, such as in factories and wind parks, to collect and immediately react to customer interactions and orders, such as in retail, hotel, travel, and mobile applications, to monitor patients in hospital care and predict changes in condition to ensure the correct and timely treatment in emergencies, to connect, store, and make available data produced by different divisions of a company, and finally, to serve as the foundation for data platforms, event-driven architectures, and microservices. So next, I would like to hand this to Nova.
Okay, thank you, Leo. And I will continue the explanation. So Apache Kafka is an event streaming platform. So what does that actually mean? Actually, Kafka combines three key capabilities so you can implement the use cases for event streaming end-to-end with a single well-tested solution. And the three key capabilities are to publish and subscribe to a stream of events, including continuous import and export of the data from other systems, to store streams of events durably and reliably for as long as you want, and to process stream of events as they occur or as they occur retrospectively. And all of these functionality is provided in a distributed, highly scalable, elastic, fault-tolerant, and secure manner. And Kafka can be deployed on the bare metal hardware, virtual machines and containers, and on premises as well as in the cloud. And you can choose between self-managing the Kafka environments or using fully managed services offered by a variety of vendors. And so how does Kafka actually work? So in a nutshell, it works by, as it is a distributed system consisting of servers and clients that communicate via a high-performance TCP network protocol. As said before, it can be deployed on bare metal hardware, virtual machines and containers in on-premise, as well as cloud environments. So Kafka is run as a cluster of one or more servers that can span multiple data centers or cloud regions. And some of these servers from the storage layer called the brokers. And other servers can run Kafka Connect to continuously import and export data as event streams to integrate Kafka with the existing systems such as relational databases, as well as other Kafka clusters. And to let you implement mission-critical use cases, a Kafka cluster is highly scalable and fault-tolerant. So if any of its server fails, the other servers will take over the work to ensure continuous operations without any data loss. And the clients allow you to write distributed applications and microservices that read, write, and process stream of events in a parallel, at scale, and in a fault-tolerant manner, even in the case of network problems or machine failures. And ships with some such clients included, which are augmented by dozens of clients provided by the Kafka community. And clients are available for Java and Scala, including the higher level Kafka Streams library for Go, Python, C or C++, and many other programming languages, as well as REST APIs.
Okay, thank you, Noval. And now I will explain the main concepts and terminology. So an event records the fact that something happened in the world or in the business. It is also called record or message in the documentation. When you read or write data to Kafka, you do this in the form of events. Conceptually, an event has a key, value, timestamp, and optional metadata headers. So here is an example event. Let's say Alice made a payment of $200 to Bob at June 25th, 2020 at 2:06 p.m. So naturally, the event key is Alice. And then the event value is made a payment of $200 to Bob. And the event timestamp is June 25th, 2020 at 2:06 p.m. So the producers are those client applications that publish or write events to Kafka, and consumers are those that subscribe to or read and process these events. In Kafka, producers and consumers are fully decoupled and agnostic of each other, which is a key design element to achieve the high scalability that Kafka is known for. For example, producers never need to wait for consumers. Kafka provides various guarantees, such as the ability to process events exactly once. Events are organized and durably stored in topics. Very simplified, a topic is similar to a folder in a file system, and the events are the files in that folder. An example, topic name could be payments. Topics in Kafka are always multi-producer and multi-subscriber, which means a topic can have 0, 1, or many producers that write events to it, as well as 0, 1, or many consumers that subscribe to these events. Events in the topic can be read as often as needed. Unlike traditional messaging systems, events are not deleted after the consumption. Instead, you define how long Kafka should retain the events through a per topic configuration setting, after which all the events will be discarded. Kafka's performance is effectively constant with respect to the data size, so storing data for a long time is perfectly fine. So here we have a graph that illustrates how it works. Yes, so you have a cluster of machines, partition A, B, and C. You have a producer that produces the keys. The keys inserted into the partition, and it will pass on to the consumers in the group. Yes, yeah. So topics are partitioned, meaning a topic is spread over a number of buckets located on different Kafka brokers. This distributed placement of the data is very important for scalability because it allows client applications to both read and write the data from or to many brokers at the same time. When a new event is published to a topic, it is actually appended to one of the topic's partitions. Events with the same event key, example Gracia, a customer or vehicle ID, are written to the same partition. And Kafka guarantees that any consumer of a given topic partition will always treat the partition's event in exactly the same order as they were written. So here we have another graph. In this illustration, this example topic has 4 partitions, P1 through P4. 2 different producer clients are publishing independently from each other. New events to the topic being by writing events over the network to the topic's partitions. Events with the same key denoted by their color in the figure are written in the same partition. Note that both producers can write to the same partition if appropriate. To make the data fault tolerant and highly available, every topic can be replicated, even across geo-regions or data centers, so that there are always multiple brokers that have a copy of the data just in case things go wrong. You want it to do maintenance on the brokers, and so on. A common production setting is a replication by the factor of 3, i.e., there will always be 3 copies of data. This replication is performed at the level of topic partitions. And also, there's the Kafka application programming interfaces or APIs. In addition to command line tooling for management and administration tasks, Kafka has 5 core APIs for Java and Scala. First, the admin API to manage and inspect topics, brokers, and other Kafka objects. The producer API to publish or write a stream of events to 1 or more Kafka topics. The consumer API to subscribe to or read 1 or more topics and to process the stream of events produced to them. And then the Kafka Streams API to implement stream processing applications and microservices. It provides higher-level functions to process event streams, including transformations, stateful operations like aggregation and joins, windowing, processing based on event time, and more. Input is read from 1 or more topics in order to generate output to 1 or more topics, effectively transforming the input streams to output streams. And then lastly, the Kafka Connect API to build and run reusable data import or export connectors that consume or read and produce or write streams of events from and to external systems and applications so they can integrate with Kafka. For example, a connector to a relational database like PostgreSQL might capture every change to a set of tables. However, in practice, you typically don't need to implement the own connectors because the Kafka community already provides hundreds of ready-to-use connectors. And then I will hand it to Faza to explain the use cases of Apache Kafka.
Thank you very much, Pandya. Now I will explain the use cases of Kafka. First, Kafka can be used for messaging. Kafka works well as a replacement for a more traditional message broker. Message brokers are used for a variety of reasons, such as to decouple processing from data producers to buffer unprocessed message, etc. In comparison to most messaging systems, Kafka has better throughput, built-in partitioning, replication, and fault tolerance, which makes it a good solution for large-scale message processing applications. Now, how does messaging in Kafka works? First, producers send message or records to a Kafka broker, and then said messages are processed by other applications called consumers. Those said messages then get stored in a quote-unquote topic, in this case, the topic is a feed name to which records are stored and published. And then consumers subscribe to the topic to receive new messages. In Kafka, messaging uses are comparatively low throughput, but may require low end-to-end latency and often depend on the strong durability that, that Kafka provides. Next, Kafka can be used for website activity tracking. The original use case for Kafka was to be able to rebuild a user activity tracking pipeline as a set of real-time published subscribe feeds. This means site activity such as page views, searches, or other actions user may take is published to central topics with one topic per activity type. These feeds are available for subscription for a range of use cases, including real-time processing, real-time monitoring, and loading into Hadoop or offline data warehousing systems for offline processing and reporting. Next, Kafka is also often used for operational monitoring data. This involves aggregating statistics from distributed applications to produce centralized feeds or operational data. Then, Kafka is also used for log aggregation. Many people use Kafka as a replacement for a log aggregation solution. Log aggregation typically collects physical log files of servers and puts them in a central place, such as a file server or HDFS perhaps, for processing. Kafka abstracts away the details of files and gives a cleaner abstraction of log or event data as a stream of messages. This allows for lower latency processing and easier support for multiple data sources and distributed data consumption. In comparison to log-centric systems like Scribe or Flume, Kafka offers equally good performance, stronger durability that guarantees due to replications, and much lower end-to-end latency. Next, Kafka can be used for stream processing. Many users of Kafka process data in processing pipelines consisting of multiple stages, where raw input data is consumed from Kafka topics and then aggregated, enriched, or otherwise transformed into new topics for further consumption or follow-up processing. For example, a processing pipeline for recommending news articles might crawl article content from RSS feeds and publish it into an article topic. Further processing might normalize or deduplicate this content and publish the cleansed data content to a new topic. A final processing stage might attempt to recommend this content to users. Such processing pipelines create graph of real-time data flows based on the individual topics. Starting with 0.10.00, a lightweight but powerful stream processing library called Kafka Streams is available in Apache Kafka to perform such data processing as described above. Next, Kafka can be used for event sourcing. Event sourcing is a style of application design where state changes are logged as a time-order sequence of records. Kafka supports for very large stored log data, making an excellent backend for an application built in this style. And finally, Kafka can be used to commit log. Kafka can serve as a kind of external commit log for a distributed system. This log helps replicate data between nodes and acts as a resynchronizing mechanism for failed nodes to restore their data. The log compaction feature in Kafka helps support this usage. In this usage, Kafka is similar to Apache Bookkeeper project. That's it for the use case. Thank you for listening.
Okay, thank you, Faza. So I think that's all from our group. And we will take questions now if there are any. And we will be happy to answer your questions. Thank you.
Okay, thank you for the team. It's very comprehensive explanation. If any from student want to ask to next group. Okay, so for me it's not question actually, but mostly like for highlighting only. So Kafka is one of the advanced, I think, the tools that I agree with your first word is always on data querying for especially for stream channel, so that will be very important to us to understand that it is can be breach and also handle many data sources from many sources that mostly close with the stream processing. Yeah. But my question is, do you found that Kafka is also can work in parallel way with many source of data?
From what I found, I think yes, Kafka can work parallel with many datas because as you said before, maybe Kafka is more advanced, and from the documentations that I read, yes, Kafka can take in many multiple parallel data from many databases.
Okay. Okay. Thank you for the explanation, and thank you for the presentation. Okay. Thank you for the team. We go to the next team. Yeah. Yes. Thank you very much, Pandya and team. We go to the next team from Muhammad Ananda Radianto Groups. Yeah.
Okay, sir. My friend will share his screen shortly.
Okay, please.
Test. Okay. So today our group will present about Elasticsearch. So our group consists of 5 members. There are Ferry, and we, myself, Farhan, Zafran, and Nanda. So let's begin our presentation. For introduction, this part will be explained by Farhan.
Okay, thank you for the introduction. What is Elasticsearch? Maybe someone will answer it's an index or search engine, maybe analytic database, and etc. So basically, it depends on your level of familiarity with this tag. But the truth is, all of the answers are correct, and that's the part of the appeal of Elasticsearch. So in the past 16 years, all the components of Elasticsearch and the ecosystems that's grown around it can also be called the Elastic Stack. It has been used for a growing number of use cases, from simple search on a website or document, collecting and analyzing block data, to a business intelligence tool for data analysis and visualization. In the in-depth of what is Elasticsearch, Elasticsearch is a distributed, free and open search and analytics engine for all types of data, including textual, numerical, geospatial, structured, and unstructured. So Elastic's first release in 2010 by Elasticsearch NV, now known as Elastic. Elasticsearch is built on Apache Machine and developed in Java. Elasticsearch is known for its simple REST APIs distributed nature, speed, and scalability make it into the central component of the Elastic Stack, a set of free and open tools for data ingestion, enrichment, storage, analysis, and visualization. Elasticsearch allows us to store, search, and analyze huge volumes of data quickly and in near real time, and give back answers in milliseconds. And it's able to achieve fast search responses because instead of searching the text directly, it can search with an index. Next, I guess the presentation will continue with Bibi or Nanda.
Yes, I will continue with the presentation. So, Elasticsearch can be used in some cases. So, we divided into two cases, the primary use cases and the company use cases. But I will explain about the primary use cases. So, the first one is in application search. So, some applications that heavily depends on a search platform for the access, retrieval, and reporting the data. And the second is website search. So some websites sometimes contains a lot of content. So Elasticsearch is maybe become a very useful tools for the websites for effective and accurate searches. And then next, the enterprise search. It is for enterprise-wide search such as document search, e-commerce products, blog search, and any form of search can be formed because of Elasticsearch. The next one is logging and log analytics. Elasticsearch commonly used for ingesting and analyzing log data in almost real time and in a scalable manner. And it also provides important operational insight on log metrics to drive actions. So, and the fifth one is security analytics. Yeah, Elasticsearch can access logs and similar logs concerning system security with the Elk stack, providing a more complete picture of what's going on across the system. And the next one is infrastructure metrics and container monitoring. So many companies use the Elk stack to analyze various metrics, which may involve gathering data across several performance parameters that vary by use case. The last cases for primary use case is the business analytics. Many of the built-in features available within the Elk stacks makes it a good option as a business analytic tools. And then the next company use cases, I think will be explained by Nanda.
Okay, thank you, Bibi. For the company use case, there are many companies that use Elasticsearch, but we are narrowing it down to only 3 companies on this presentation. That is eBay, Walmart, and also Netflix. For eBay, eBay has built a customized Elasticsearch as a service framework for easy supply of Elasticsearch clusters on an internal OpenStack cloud platform via countless business critical text and reviews using cases that use Elasticsearch as the backbone. And second, for Walmart is in order to gain insights into consumer purchase trends, stock efficiency metrics, and also holiday reports, Walmart uses Elastic Stacks to expose the secret potential of his data, all in a near real time. And it also uses ELK protection features with SSO and anomaly detection warning and DevOps monitoring. And lastly, we have Netflix, which in various applications, Netflix use ELK stack to monitor and analyze the operations and security logs of customer services. The basic motor behind their message system is Elasticsearch, for example. And furthermore, Elasticsearch was chosen for automatic sharding and replication also flexible design, nice expansion model, and also a multitude of plugin ecosystems. From a few isolated implementation, Netflix has gradually expanded the use of Elasticsearch in more than 12 clusters of hundreds of nodes. Next one is the type of data that can be sourced will be explained by my friend Ferry.
Okay, thank you. So I will explain about the type of data that can be sourced by Elasticsearch. So Elasticsearch supports different data types for the fields in a document, and each of those data types offers its own multiple subtypes. This allows us to store, analyze, and utilize data in the most efficient and effective way possible, regardless of the data. The example of type of the data is text, shapes, numbers, vectors, histogram, data or time series. Date or time series, flattened field, geopoint or geoshapes, unstructured data or JSON, and structured data. And the next is how Elasticsearch works. It will be explained by Severn.
Okay, and for the process, we collect the data from the various sources, including the logs, device metrics, and web applications, and then flow into the Elasticsearch. The data intake is a process through which this raw data is parsed, normalized, and enhanced in Elasticsearch before it can be indexed. Users can then run complex queries against their data after they are indexed in Elasticsearch and use aggregations to retrieve the complex summaries of their data. And the Kibana here can provide users with powerful data displays, share dashboards, and control the Elastic stacks. The unstructured data are stored, indexed, and searched based on the user-specified mapping from different places, which can also automatically be extracted from the data. Its distributed architectures allows the large volumes of data to be searched and analyzed in almost real time. And I guess that's all from our group. Is there any question?
Okay. Okay, thank you very much for the presentations. Yeah, this is about the Elasticsearch. Do you find that the actually like Elasticsearch have a lot of also ecosystem, yeah, by their own? Yeah, we have Kibana too and etc. You found that too for the Elasticsearch discussion?
Yes, actually we found that, but we didn't include them in the report.
Okay. Yeah, actually, when we see Elasticsearch, is actually like same the position like Hadoop. Yeah, it's same as platform. If like Kafka, maybe like previous one Storm or Solar is used in the HDFS, but the Elasticsearch is they have their own environment to work with many tools. Yeah, so that's very interesting actually for Elasticsearch. This is also one of the other option that we can consider as big data platform. Yeah. Okay, thank you very much for the team that present the Elasticsearch. Enjoy your presentations. Okay, and then we go to the next is, I think now go to Adam, the team of Adam Ibnu Fiadi.
Okay, good morning, sir.
Okay,
I want to present my screen. Can you see my screen already? Okay. Assalamualaikum warahmatullahi wabarakatuh. For today's report, my team and I are going to report about the Pentaho data integration tool. My team consists of 3 people: me, Adam, Don, and Hafid. Okay, for the presentation is the Pentaho. So what is a Pentaho? So Pentaho is a business intelligence tool which provides a wide range of business intelligence solution to the customers. But for this report, we will only discuss about the Pentaho data integration tools, because Pentaho provide another set of tools like for reporting or data analysis or data mining and etc. So Pentaho also offers a comprehensive set of BI business intelligence features, which allows us to improve business performance and efficiency. So the data integration, or the PDI, is the process of combining data from different sources into a single unified view. Integration begins with the ingestion process and includes steps such as cleansing, ETL mapping, and transfer. This ETL means that for extracting, transform, and for loading data. So data integration ultimately enables analytics tools to produce effective and actionable business intelligence. For the next, I will go to my friend Hafid. Don, I'm sorry.
So now I will explain about the purpose of Pentaho data integration tool. So the first, oh, sorry, let me share my screen instead. Okay, so the purpose of Pentaho data integration is to collect massive data. It is well known for its ease for to pick up. Sorry, it's easy to learn, and it's easy to learn. PDI implements metadata-driven approach, which means that the development is based on specifying what to do, not how to do it. Pentaho lets administrators and ETL developers create their own data manipulation with a user-friendly graphical creator, and without entering a single line of code. PDI uses a common shared repository, which enables remote ETL execution, facilitates teamwork, and simplifies the development process. Pentaho also offers function for data analysis, porting, data mining, and data visualization. Now, what type of data could be used in the tools? Pentaho reporting is a suite or collection of tools for creating relational and analytical reporting. Using Pentaho, we could transform complex data into meaningful reports and draw information out of them. Pentaho supports creating reports in various formats such as HTML, Excel, PDF, text files, CSV, and XML. Pentaho can accept data from different data sources, including SQL database, OLAP data source, and even Pentaho data integration tool. And there are a lot of data types supported by PDI as well, which includes some basics like string, integers, numbers, big number or big int, date and timestamp. So first, let me explain how does the tech work and the process and the components. First, the tech works by an application called Spoon, which enables users to build transformations and jobs. Transformations describe the data flows for ETL, such as reading from a source, reading from a source, and then transforming data and loading it into a target location. Jobs coordinate ETL activities such as defining the flow and dependencies for what order transformation should be run, or prepare for execution by checking conditions such as, is my source file available, or does a table exist in my database? Basically, transformation and jobs is almost very similar, but I believe jobs is more sequential in a way, in how it works in the flow table. In the data flow. So next I will explain about the processes of how it works. First, you open the Spoon app, and then basically there are a lot of tools available. Let me show you in the Spoon app first. You have a lot of tools available for the data flow. And first you could choose a lot of input types. And then basically how it works is you add one input, and then you add tools to then work with the data, such as, for example, filtering. There's actually a filter function, but the search function is quite broken. So, and then lastly, you could just directly output your input into a table in a way that you send it directly to your database. Text file input could be in the form of a CSV file, for example, and then you output it into a table in your database. And then this is the explanation of what I just did. You load the data, or you load your input, and then basically it works by creating a data flow. Yes, you can add multiple tools between the output to let you process the data first, for example, like I said, filtering, for example. And here, actually in the trial, when we researched this, we tried a testing for data, and from Pentaho itself, they gave us example data of sales support. And then in the sales report, there are many customers that didn't include their zip codes while they ordered. So therefore, we must filter first for the customers that didn't include the zip codes, and then prevent the data from being inputted into our database. This is done by actually putting a filter function between the input and the table output. Then basically, if we run this transformation at this state, it would result in the writing of data to the database, but the only data is written into the database is the only the customers that only included their postal codes. So the customers that did not input their postal code would be written into the database. And then using Spoon, it also allows us to resolve the missing data. From the early explanation that I gave about the missing postal codes, we could actually use another input. In this case, Pentaho also gives us a source file about list of postal codes according to the state and the city. Therefore, we could use it to read the state and city of the customer that didn't put their postal codes in, match them together and find their postal codes, then write them into the table output. And another function is to make clean data. After resolving missing data, we could cleanse the data and categorize the data into buckets before loading it into the RDB. This process is meant to categorize different data names with same value. For example, the source file, the sales report, has a country filled with its column name containing data from USA and United States. Cleaning the data will ensure there will be only one version, which is USA. And it is by adding the value mapper function, which is basically explains that every data that passes the filter zip code or did not pass the filter zip code will run into this function, the value mapper function. Therefore it would try to find the country data, which has the country written as United States and change it into USA. And then after that, we could run all of the transformation, and then therefore we would get a more complete data and more clean data rather than we would just run it at the first step by adding an input and then output directly. The sixth one is job orchestrates. Jobs are used to coordinate ETL activities, such as defining the flows and dependencies that control the linear order for the transformation to run, preparing for execution by checking conditions such as is my source file available or does a table exist, performing bulk load database operations, assisting file management, such as posting or retrieving files using FTP, copying, and deleting files, and also sending success or failure notifications through mail. And next from the components, I will pass it on to my friend Hafiz. Thank you.
And so for, okay, let me present my screen. And so for the last part of Pentaho is Pentaho's components. There are three main Pentaho's components. The first one is data integration server, and the server provides DI repository, processing engine, and service layer and scheduling. And then there is design tool and command line utilities. As Don already explained earlier, we use Spoon for the app to use Pentaho. With Spoon, data integration exists with variety of tools. This type of layout is also easing the data processing by making data flow with certain steps that the user needs before continuing further to work with the data, like filtering, for example, like Don already explained. And then other tools like CART provides the creation of a dedicated remote PDI server to coordinate jobs with larger cluster of computers. And the last component of Pentaho is plugin and command line utilities. As we install Pentaho in our computers, there are already two plugins comes by default. They are InstaView and Agile BA. InstaView could set complex series of data access and preparation. It also automatically generates transform and metadata models, execute them, and allows them to visualize the result. Meanwhile, Agile BI allows the viewing of changes to the data mart or models without leaving Spoon. This helps data processors to work more efficiently. That's all from our groups. Thank you for the attention.
Okay, thank you very much for the group that explored the Pentaho data integration tools. I see that you also do some very little bit experience, yeah, to do that one. So it's nice. Yeah, the Pentaho is one of the also advanced tools that used for actually for ETL process, yeah, extract, transform, load, especially when we deal with the data sources from the database management system or mostly databases. Yeah, so that's we can make a lot of and complicated transformation and then places to our data mart. So yeah, I think that's good things, and thank you very much for the detailed explanation about Pentaho. Okay, so I think we have running out of time, so we still have about 1, 2, 3, 4, 5. I think 5 teams still not present yet. So 4 or 5, yeah. Okay. So I will postpone until next week. So next week will be turn for Muhammad Yusuf, Sarah, Fabian, Nicholas, and Arif team, yeah, to present the work. Yeah. And okay, I think that's it for today. Any question from you, from student?